Hello students, in this video we will discuss about Sun Network file system. So a distributed file system uses two methods. One is Sun Network file system and the other one is Andrew file system. So Sun Network file system is also known as Sun NFS. And this is a network file system developed by Sun Microsystems. That is why it is known as Sun NFS. And it allows a user on a client computer to access files from the remote server, and the communication between the client and server is taking place through a remote procedure called. This is the Sun Network file system architecture. It have a client computer and a server computer. The various modules included in the client computer are a virtual file system, Unix file system, NFS client. There will be an NFS protocol to communicate between the client and server, and an NFS server, virtual file system, and a Unix file system. So what is meant by a virtual file system? This particular module, that is this virtual file system, this is used to distinguish between the local and remote file. That means whenever a request came from the user, this virtual file system will check whether the requested file is a local file, that is whether it is present in the client computer itself, or a remote file, that means the file in the server side. And the file identifiers used in NFS are called file handles, and it have three modules. One is file system identifier, second one is inode number of the file, and the third one is the inode generation number. So file system identifier means it is a unique number that is allocated to each file system when it is created. And inode number means this is used to locate the file in the file system, and it is also used to store the attributes of a particular file. Attribute means the length of the file, read, write, timestamp, etc. And this particular inode numbers can be reused. That means for every file there will be an inode number, and if that particular file is deleted, this inode number can be used for another file. That means it is reused. And the next is inode generation number. This is like a count variable, and whenever an inode number is used again, inode generation number will be incremented. It is needed to increment each time inode numbers are reused after a file is removed. Next is the NFS client integration, and this particular NFS client module cooperates with the virtual file system in the client machine. So whenever the request for the file is local, it will access the Unix file system for the local file. Okay, from this particular database, Unix file system will access that local file. And if it is remote, the NFS client module will send a request to the NFS server. NFS server interface, this is stateless and does not keep files open on behalf of its client. Stateless means once a connection is established between the client and server, no more information is stored. So in that case, the server must check the user's identity. That means whenever a request is arrived at the server side, server must check the user's identity, whether that particular user is having the permission to access the file on the server computer. And these are some of the NFS server operations: lookup, create, remove, get attribute and set attribute, read, write, rename, link, and read link, mkdir, rmdir, etc. Next is the method of naming. It is defined as a mapping between logical and physical object. That means when the user refers to a file by its textual name, it will be mapped to the disk blocks. And the next is path name. Files are named usually by some combinations of machine or host name and path name, and this is used in the server side. The next service is mount service. That means the remote directories are mounted to local directories. That is, the remote directories will be combined to a local directory. This is the mount operation. Mount, localhost, remote directory, local directory. A remote directory will be combined to a local directory in the localhost. Consider this, we have a client and we have two servers, server 1 and server 2. Both the server directories, that is the remote directory, will be mounted to this particular client directory. So we have two staff and student directory. Whenever any user send a request for the details of staff or the file about the staff, the request will be sent to particular server 2 because this directory is mounted over the local directory, and if the details of students are required, it will send a request to server 1. This is called mount operation. And the mounts can be of three types: soft mount, hard mount and auto mount. Soft means there will be a time bound. That means the mounting operation combining of the remote directory to a local directory should be completed in the specified time, otherwise there will be a failure message. And hard mount means there is no time bound. The combining can be the mounting operation can take place at any time, and if any kind of failure occurs, retry can be done. Next is auto mount, and this type of mounting operation, in this type mounting operation will be done only on demand. Next is the client caching. So in the NFS client module there will be a client cache, and this particular client cache will save the results sent by the server, and this is done to reduce the number of requests transmitted to the server. And a timestamp based method is used to validate cache blocks, and the communication is secured using Kerberos. It is a protocol, NFS protocol. And server cache. In the server module there will be a server cache, and this cache will hold the recently read disk blocks. And a data in write operation, that means if the client send a write request to a server, and the data in the write operation received from the client will be stored in the memory cache at the server, and this particular data will also be returned to the disk before the reply is sent to the client. This is called write through caching. The other method is the data in write operation is stored only in the memory cache, and it will be returned to the disk only when a commit operation is sent by the client to the server for the relevant files. So this is the architecture that we have already seen. Suppose think a user send a request for a particular file. First it will be through the program interface, it will be sent to the virtual file system, and in the virtual file system it will check whether the file is a local file or a remote file. If it is a local file, the access will be given to the Unix file system. So Unix file system with the file identifier number, it will identify the file from this particular database and will give to the user. But when the virtual file system identifies the request to be a remote file, it will be forwarded, the request will be forwarded to NFS client module, and NFS client module will send the request to the NFS server module to get that particular file, and the communication is taking place through RPC, remote procedure call. So the stub module in the client side will marshal the request and will send it to the server. So on the server side, unmarshalling will be done and will send it to the virtual file system. So virtual file system will identify the file system identifier number and will send it to the Unix file system, and will access the particular file from this particular database, and again it will be sent to the NFS server module to give the reply or the result back to the NFS client module. Again marshalling will take place at this end, and here unmarshalling will take place, and the result will be delivered to the client. This is the working operation of a Sun Network file system. Thank you.